Hello everyone. Today we are going to talk about machine learning with GPU clustering on Kubernetes project done by me, Rahul Akineni, and my teammate Yashaswini Suryadevara under the guidance of Dr. Wahid Behzadon. So our objective was to set up a Kubernetes cluster on a bare metal that runs Jupyterhub and provides user authentication and allocates all the GPU and other computing resources to the users based upon their authentication and priority. Now we are going to talk about Kubernetes. Kubernetes is a container orchestration tool. Why are we using a container orchestration tool? Because we are using a container called Docker, where we are going to install our Jupyter Hub and maintain and run that service. So to maintain all the Docker and its resources, such as pods in the Docker, we are going to use Kubernetes, which helps us to manage the Docker and our Jupyter Hub. Why we are using Kubernetes is because it's a high availability software where that means we are gonna create nodes which talk with each other, communicate with each other, and one works as a master while other works as a slave. But while using Kubernetes in high availability mode, we can may any node can act as a control plane, that is as a master node, while the other will act as a slave node. We can also use the scalability power of the Kubernetes, which helps us to scale to the number of users that are using the Jupyter Hub on our service. And we can also use the disaster recovery, which helps us to recover from all the crashes and other errors that occur during our process. So the Kubernetes is first invented by Google. So all the Google cloud will be running on Kubernetes, while Google is not the only one using the Kubernetes. As you can see, Slack, Udemy, and everything else are using the Kubernetes right now. So next we are gonna talk about the Jupyter Hub. So Jupyter Hub is a way where multiple users can run their Python scripts and they can use it. It is a modern data science tool which helps the data scientists to develop their Python scripts, run their models in a cell by cell way, so that it is an interactive way to run Python scripts. So this will be our service that we are going to install on our Kubernetes. So this is the architecture of the Jupyter Hub, where this is our hub pod, and while every user will use a IP address that we provide, and they will be directed to the hub pod. And using the configuration file of the hub pod, each user will be given their pod based on the authentication we have given them. So once the user is authenticated from the admin and the database, then he will be given a pod which is provided by a spawner, and they will have their own pod running their own Jupyter Hub service without anything to install on their laptop. So this will be the Kubernetes architecture. So as you can see, there is a control plane and the computing machines. So the control plane will run all the required services such as API servers and schedulers to maintain and manage all the services running in the Kubernetes cluster. Whereas the compute machines will have the proxies and the pods and containers which run the actual services. And you can see that the volume the storage is provided by a persistent volume storage, and the container registry will be used to authenticate the users. So this is the Google Cloud setup, and as you can see, the UI of the Google Cloud setup and how the services are running on the right, where all the services are running, and how the Jupyter Hub is available from an IP address highlighted from the above picture. If you just type the IP address in your browser, you will get the Jupyter Hub after being authenticated. So this is the bare metal solution we got. And as you can see, all the pods are running, which shows the green, and the below image shows how much resources each of the pods are using. And on the above, we can see the Jupyterhub running images. So this is the storage solution provided. The persistent volume provisioner used is an NFS provisioner. You can see all the services are running and the pods are being scheduled, and each PVC has been claimed using the NFS client. So the actual deliverables and goals we set in mind were Kubernetes setup and Jupyter Hub running on the Kubernetes with a dynamic persistent volume provisioner and authentication. While we have done the above three, we were unable to create the authentication, which will be our future scope. So the demo will be given by my teammate Yashaswini Suryadevara. Yashaswini, please take over.
Thank you, Rahul. Hello, everyone. I'm Yashaswini Suryadevara, and I'll be giving a detailed technical demo of how to set up Kubernetes cluster and how to deploy Jupyter Hub on bare metal. All right. The first step is to SSH into your master and worker nodes. So I have already done that. I have three Ubuntu 20.04 T2.medium EC2 instances. I have a detailed documentation of how to set up Kubernetes cluster in my GitHub repository. So the minimum requirement is that the master node with at least 2 GB RAM and 2 CPUs, and the worker node with at least 1 GB RAM and 1 CPU. And we need to run all these commands as root user in both the master and worker node. So first you need to disable the firewall and disable swap. And then you need to run these parameters. And again, you need to install Docker engine. First, you need to install the prerequisites, then add the key for the Docker, and then add Docker repository and install Docker. Next, you have to set up Kubernetes. For that, you need to add the key and then install the Kubernetes components. So next step is run only on masternode, that is Kubedium initialization. So you need to replace the IP address with your masternode IP address. And after that, you will obtain a output which will be using in will be using in the worker node to connect to the master node to make a cluster. So you need to run all these commands in as non-root user so that you can run kubectl commands as non-root user. So after that, you need to run these the Calcio network. To deploy the Calcio network, you have to run this command, and you can exit it, and you can run kubectl commands as non-root user. And after that, you can join the cluster using the token we have obtained from the step 7. And I have already done this. Let's see if all my nodes are ready. kubectl get nodes, and you can see that my worker nodes have joined the cluster. And after this, we need to set up MetalLB. So MetalLB is a load balancing solution that you use on bare metal clusters, which provides you with load balancing solution. You can expose your deployment through load balancers with the help of MetalLB, either Nginx, Jupyterhub, or whatever deployment it is. So first you need to install zipcalc and run this command to find the usable range of IP addresses to set MetalLB. And you need to follow these steps to set up MetalLB and check the components. You can run this command in your master node to check if everything is ready. You can see that all the pods are running and the deployment is ready. So after that, you need to set up a layer 2 configuration. The config mac file details are here, and you need to replace these with the IP addresses you have found using the zipcal command, and then apply it. And you can use your Metal LB, you can receive the external IP for whatever deployments you make. And after this, you need to set up NFS external provisioner. So the NFS external provisioner creates persistent volumes and gives storage. And the prerequisite for this is that Kubernetes should be greater than or equal to 1.1.9. So let's check what our Kubernetes version. You can run kubectl version short. As you can see, our version is 1.20.5. So you can go ahead and install the NFS server by running these commands, and you have to make a directory and make the permissions, change the permissions to nobody, and then you need to give access to the NFS server by running these commands, and then enable the NFS server. And you run this command to show the directories that are being exported to NFS. You can run this command and you can see that what directory is being exported. You can see this is this is the directory that's being exported. So the important thing is that you need to log into your worker nodes and check that the NFS volume is mounted on the worker nodes by running these commands. You need to install NFS common and run this command by replacing the IP address. This is mandatory step. If the mounts are not, the NFS volumes are not mount, your dynamic provisioning will not be working. So after that, you can install Helm, because we'll be using Helm to install the NFS provisioner, and you can add the repository for the provisioner and then install the NFS update external provisioner. So let's check if it has been deployed by running this Helm list command in our master node. So you can see that the NFS external provisioner has been deployed. So now you can go ahead and install Jupyterhub. I have made the storage class as default. So these are the steps you need to follow to install Jupyterhub on bare metal. This is just to give the secret token to provide security and install Jupyterhub by running all these commands. So let's check if my Jupyterhub is deployed. As you can see, the Jupyterhub is deployed. And let's check if everything is running. You can run kubectl get all, check if everything is working fine. You can see all the pods are running, all the services are ready, and we have received an external IP thanks to Metal LB. And now you can go ahead and run this in our web browser, and you can see the Jupyterhub running. And I'll show you how to set up Google Jupyterhub on Google Kubernetes engine. It's very simple. You go to your Google Cloud platform and click on Google Kubernetes engine, and you can click on create and click on configuring standard Kubernetes cluster. And you can customize it. You can change the name of the cluster. You can change the image type to Ubuntu with Docker or whatever you prefer. And you can change the security to full access to all cloud APIs. And you can make the necessary changes you want and just click on create. I have already created a Kubernetes cluster, and I have already installed Jupyterhub on it. I will show you back nodes. Let's see, it'll get nodes. You can see that all the nodes are connected, and let's see if the pods are running. Okay, now all the pods are running. Let's get the service, and you can see it has external IP. You just need to copy this and paste it in your web browser to access your Jupyterhub. You can give any username and password. You can give any username, like You can give any username. You can give my name, and you can give your password and any password, and you can just sign in. It will create your own notebook. So each user will be allocated with a persistent volume and storage. You can see that every user is allocated with a persistent volume claim to save your data. So this is going to take a moment. So this is how you set up Jupyterhub. I have made a detailed documentation of how to set up Jupyterhub on Google Kubernetes and in Google Kubernetes Engine too. So you can just upload your notebooks or create a new Python file and your data will be saved. So you can provide user authentication too. You can provide user authentication in Google Cloud by authenticator. You can just go to search for credentials in Google Cloud Platform, and then you can create credentials or client ID, and you can select the web application type as web application. And you need to, if you have any URIs, you can add them and just click on create. After creating, you have to go to OAuth consent screen. When you create it, you will receive a client ID and client secret. You need to save those to use them in the config.yaml file. And you can create an app for that. I have already done that, but we are not completely done providing the user authentication. We're still working on it. So our next steps would be providing user authentication and role-based control access to the Jupyterhub. And after that, we'll try to enable GPU to work with Jupyterhub. And that's it. Thank you.